All right. All right. Hi, everybody. Welcome to today's stream. Hope everything's all right with you. Happy Tuesday. Another day in paradise. Let me quickly see if it's live on LinkedIn. Send a quick hello if it's live, if you can see me. Yes, I think it's live. Yeah. I think it's working. All right. I see the first one. Togrul, hi. Hey, how's it going? All right. Manchu, hello, Sunil. Hi. Okay. It works. I don't know. Sometimes it doesn't show me here on LinkedIn that actually somebody's here, but I can see you. All right. Welcome to today's stream. I was looking at how many streams did I do until now, and I got here to 100 and what's that? 128. Was it 128 or did I mess it up? I think I messed it up. I think it's 148, but it doesn't matter. I'm going to change it afterwards. Hey, Ankit, just a few names. Muhammad, hello. Hi, everybody. Yeah, so if you have questions, put them in the chat. We're going to talk about data engineering. I titled this, so it should be 148. Data Engineering Roadmap 2023. That's something I see people post about it. And actually, so let me show you what I'm talking about, and we're going to go to this in a sec. I'm talking about this thing here. The interesting part is people reposted this on LinkedIn as Data Engineering Roadmap 20. Sorry. Can you see my mouse now? Yeah. The interesting part was people posted this on LinkedIn and they just changed to 2021 to 2023 and let everything the same here. And I like, yeah, Ruchil, we're going to Python or Java. We're going to get to that later. So this is something we're going to talk about today. We're also going to talk about a project that somebody posted on LinkedIn about Spotify, where they used the Spotify API and then basically took the data out of it and processed the data from Spotify with AWS. It's a subpar project. I think there are a lot of options to change or to make it better. So we're going to look at that. And we're going to start with Spark versus dbt versus Pandas. That's the first thing. Hi Krishnan, welcome. So that's the first thing, Spark, dbt, Pandas. If you were here a few days ago, we were talking about the state of data, where they asked over 800 engineers and data people, what's the most use, or what are they most positive for data transformation wise. The most people here said dbt. Here, dbt. Then came Pandas, and then came Spark, right? So dbt leading, then Pandas, then Spark. Oh no, the other way around. Pandas was leading with 488. Then was dbt with 469 and Spark with 320, right? So that was something I wanted to test this. I wanted to ask my followers on LinkedIn, like, how do you use it? What are you using most? And from my people, what we found out here was with 500 votes, it's up to 500 now. I posted this, when did I post this? 4 hours ago. Spark is actually leading, and then Pandas, and then dbt. So it's DBT isn't in as big of a lead as other people. We're saying, yes, this post was about my Databricks, or was it Spark course? No, Databricks course. Doesn't matter. People were coming here to this question: which tool do you use most for data transformation? Pandas, DBT, Spark. Pandas actually gained on Spark. Earlier, it was Spark was a lot further, or was more towards Spark. But so I don't know what you think. Like, why is this different than what we've seen before in this state of data? Or was the state of data more towards what do you, because they actually named this brand recognition and adoption. Yeah. So it's so much different, because when we were looking at this, I was saying like, oh, it's because a lot of people work on the analytics use cases and they are doing a lot of transformation with DBT in the data warehouse because it's easy. But from this post, I don't know what you think. If you haven't voted here, go there, vote there, or write a comment in our chat here. What you think. So that's one thing. Was a bit surprising. I was thinking like somebody named here. Alexandra actually said, "Is there an option for DBT?" But wishing it was Spark, because Alexandra also thought DBT is going to win big here, but doesn't really look like it. Yeah, I don't know why. Like, post in the chat if you're here. For everybody who's here, for everybody who's here, do me a favor, post in the chat now, which one are you using most and why? Maybe a short why. Would be very interesting to see what you think, because from what I got from the poll, it's could be I would need a bit more insight why people, because Spark, I don't see Spark winning here, because Spark comes with a lot of overhead and with a lot of like a steep learning curve. And Pandas, I was saying, like, Pandas, I said this last time, it's very easy to use. If you have a computer, you can do it. You can run it anywhere you want, and just a simple Python script. So DBT actually surprised me in this. Let me get my drink here. DBT actually surprised me. Somebody says here Spark. Okay, so another vote for Spark. All right. So I don't know. That's something I have here on my mind, and it's always surprising. Pandas, reason, amount of data. Yeah, Camilo, exactly. If the amount of data is low, why would you go with Spark or Databricks? If you can do it in Pandas, then doesn't matter. DBT, Sun says DBT decentralized the transformation. Data analysts can do some stuff rather than waiting for data engineers. Absolutely, yeah. It's and also the other way around, right? Because now with DBT, if you're a data engineer, you can already prepare stuff for the analyst. If it's already built in, it's very simple to say, okay, we're going to do this before even a data analyst comes in. We know our goals. Let's do this. So, yeah, very nice. Decentralized. What did it say? Decentralized the transformation. Yeah. Also, if I mean, DBT is also good if you have a large team of engineers. and they can also work for the analysts there. Using Pandas for data transformation because it's easy to use. Don't hear about DBT yet. If you're working with some kind of a warehouse or analytics solution like DBT, like Snowflake, like BigQuery, like Azure Synapse, Redshift, DBT absolutely makes sense because with DBT you can very easily create transformations. I think I didn't do a video on DBT, but I have a course on my website about DBT where you can check out a bit. Let me bring it up, where you can see a bit what is this actually about. Let me bring it up. My courses. DBT. Where is it? DBT for data engineers. I should have done this differently. This is not how I want to do this. I think you get. Yeah, I think you get the idea, right? It's gonna show this. Let me open up a incognito window. Do we have a image here? Here we have an image. Okay. This is straight from the course. And this just shows you a bit what you can do with DBT. You can take the data, for instance, from files and use Snowflake, for instance, the stage, and put it then into Snowflake. And once the data is in Snowflake, right, usually you do ETL. You do the transformation here before you actually put it into the stage. With DBT, you can do ELT, so the processing actually happens. I'm looking into the wrong camera. So the processing actually happens in the database itself or in the warehouse itself. So that means you take the data, you just write it into Snowflake, and you keep it into Snowflake. Then in DBT, you create your transformation logic. And I know this looks like the processing of DBT is doing the processing, but this actually DBT is only doing in English sometimes it's hard to explain. It's basically only saying to Snowflake, do this and do this and do this. And Snowflake internally then actually transforms the data and creates, for instance, then the dimensional tables for the use cases. So that's the goal of DBT. Yeah. I use Spark and Pandas. I never get the chance of using DBT. It's very easy. So if you're, as I said, if you're using some kind of a warehouse, of the big warehouse, it's easy. It's very nice, very simple to learn, very nice to use. Tidyverse and specific packages for specific data types. Okay. I don't know that. Yeah, DBT, the versioning and the data lineage part of DBT is very, very interesting. And that with the versioning that it's so closely integrated also with GitHub. Super cool, so super nice to use. And it is really helping people in these organizational things. Versioning, scheduling as well, and what did I say? Data lineage. Super cool. Okay, so then we have that. Let's move into the data engineering roadmap before we go into the next thing. So the data engineering roadmap, we all know this, or I'm guessing you know this. Where is it? Where is it? Where is it? Here. It's on GitHub from Data Stack TV, data engineering roadmap. Here, did I already post this on Twitter? Let me see. Otherwise, I'm going to post this for you on Twitter so you can access it. No, data engineering roadmap. Well, let me quickly post this here. Data engineering roadmap 2021. All right. So you are going to find this on my Twitter if you want to look at that. The state of data, I think we had yesterday. Yeah, link to that is here. Okay, so where is it again? Here. So that was, you know, I usually don't really like these kind of roadmaps because not everybody should learn everything here. But for pointing out what are the interesting parts, I think that it's very good. So let me quickly do it like this. Okay, so let's create a roadmap 2023 here and use this of what is important. What we're going to do is I'm going to go in and I'm going to just mark stuff here with the circle. I'm going to mark stuff with the circle. So Git version control from this computer science fundamentals or the software development fundamentals, I would say, that is something you should look at. Basic terminal usage, sometimes you need structures and algorithms. That's more for the coding, for the programming. If you know this, you should know the data structures from a coding language. So let me mark this. APIs and REST is usually coming later. It shouldn't be the first part, but APIs, that's something structure. So let's not get too much into this. Linux, not everybody needs Linux knowledge, but it's good to know. Right? So that these things are already worth looking at, and I see I'm already messing this thing up here. So look into Git, look into Linux, and basically what are the basic Linux things. You can learn this on your WSL on Windows. Set up a WSL and Windows subsystem Linux and use that a bit. It's absolutely easy. Cron jobs is actually, I would mark cron jobs here red, because easy shed, you don't need to run Airflow for everything. If you just want to have a script and you want to quickly schedule it, use a cron job. I have started with cron jobs as well. So cron job, use a cron job. It's absolutely okay. Then, as I said here, data structures and algorithms. For me, that's also connected to the programming language. And what I would go there, when we scroll down here, the main one for me is Python here. I would absolutely go with Python. I would not go with Java, not with Scala, not with Go. If I would start now, I would go with Python, because Python has so many options. We were talking about Pandas before. Very easy to use. You can do it on any computer. If you have Python installed, you can work with data. So I would start with Python here. Java, Scala, Go. No, I wouldn't go. Testing. At least you need to understand unit testing. Okay, that means you have a piece of code, and that you're able to test your code, and not put it into production and then everything fails. So that integration testing is more towards, okay, you're preparing the data and so on. But so the testing part, yeah, absolutely. Database fundamentals. Yeah, exactly. Thomas says it here. I can't click it. Thomas is saying here maybe Unix rather than Linux, which is a good point. It's more general. Yeah, but let's keep with Linux. So SQL here, super important, and normalization, this kind of things that you understand. How does a relational database work? I would say here this is RDBMS, Relational Database Management System. You should be able to understand our relational database management systems. That's everybody needs this. Yes, SQL, basically how can you query stuff, but also normalization. That means how can you, if you have a data set, build a simple database with it and normalize this into tables and with primary and foreign key constraints. So key relationships. So that's important. For me, then, what you should focus on here, I mean, horizontal versus vertical scaling. This is very simple to understand. It's no big deal. Dimensional modeling makes sense. Let's mark it here. Yes, but only half. And the important part is that you understand this, that you understand the goal or the difference between OLTP, which this part is here, relational databases, and OLAP. They're coming later. Relational databases are actually coming here below, and OLAP, which are data warehouses, where also dimensional modeling is part of. So let's move further down here. What do we have here? Relational databases. It's difficult to say which one you should start with. Nowadays I would start with Postgres. It's so easy to install. It's so easy to use. You can't do something wrong with Postgres. Or I started when I was working with data. I started actually with MySQL. So this MySQL, very, very nice. You can learn a lot. MySQL also has a great editor. How's that called? MySQL Studio, MySQL Workbench. It's called Workbench. MySQL Workbench is something. When I learned all this, I was working with MySQL and the Workbench, because you also can do visual stuff in the Workbench, and you can visualize the tables and modify them visually. So MySQL Workbench and MySQL, it's also a safe choice. Then NoSQL or non-relational databases. I think here the main thing would be MongoDB. That's for me. Forget about Cassandra. Forget about HBase here. Google Bigtable. Cosmos DB on Azure, if you're there, yes, use that. Elasticsearch, I would say, let's make this not a circle. Can be very, very helpful. I also have that in my academy, because like for log monitoring and searching through logs, Elasticsearch is really, really, really good. So that can help. Neo4j, no. Neptune, no. Redis, no. Memcached, no. DynamoDB, no. Because DynamoDB also works as a document store, and there, if you have MongoDB here, yeah, it's pretty simple. A question here for why is shell scripting required? here. Why is shell scripting required? Well, did I actually mark this here somewhere? I don't know. I don't think so. I'm not the big shell scripter myself. I haven't really gotten for modern data engineering. I don't think so. So forget about shell scripting. It's not super important because if you want to script something, most likely you're going to do something with Python. So yeah. Data warehouses. Let's go through the warehouses. Of course, Snowflake here. Boom, Snowflake, yes, 100%. Presto, forget about it. Hive, forget about it. Impala, no. Redshift, okay. Let's mark this. Redshift if you're on Amazon. Also interesting. BigQuery, 100%. But choose only one here. Don't do all, right? Okay, don't do all. Just choose one. And if you're on Azure, Synapse is a no-brainer. You should go with Synapse. ClickHouse, forget about it. Same thing, cluster computing fundamentals, Hadoop, forget about Hadoop, HDFS, don't really need MapReduce, you don't really need. Lambda architecture is the important part here. Kappa architecture, niche, absolutely niche. I know people love to argue Lambda architecture, Kappa architecture, but Kappa architecture is better with streaming and so on, and almost nobody uses Kappa architecture. Forget about it. If you understand the Lambda architecture with its two paths, streaming and batch processing, you're fine. Absolutely fine. It's going to be great. So that's my tip here. Manage Hadoop. Forget about Hadoop. No. EMR is good for running Spark jobs. A lot of people say this to me. So although I also like Glue here. Glue. So AWS Glue, also very interesting in this part. Again, with the warehouses, I marked here a lot. Don't use everything. These three, depending on where you are, absolutely. I would absolutely, you need these. So you need some kind of a data lake, depending on where you are. If you're on AWS, of course, you're going to be use S3. If you're on Azure Blob Storage, if you're on GCP Cloud Storage, same thing. Works literally the same thing. So it's fine. It's fine. Data processing. Okay, now we're coming to the data processing. Okay, batch processing, Pig. Forget about Pig. No. Arrow. No. DBT. We were talking about DBT before. Absolutely. DBT gets a red dot here. Good. Spark. Absolutely. Yes. If you're on GCP, you can use Beam. Yes. Flink. And a lot of people are going to hate me about this. Still too much niche. Apache NiFi also niche project. Beam, if you have to. Kafka, you should understand Kafka because Kafka is the basis for every message queue out there. So Kafka is a must-have. Storm, forget about Storm. Nobody's using Storm. Samza, I mean, Kinesis is here. If you're on AWS, you want to use Kinesis, right? Same thing here with PubSub. Google PubSub is this, I don't know why they put this into different categories here. PubSub is the same like Kinesis. So it's if you're on AWS, if you're on GCP, good to know. If you're on AWS, these simple notification service and simple queue service, you should like understand these, right? So let's I don't know, let's do this. There were questions. Messaging here, RabbitMQ. Active. I don't know. I don't know why this is green. Like, I know. Kafka and Spark streaming both are they both the same? No, Kafka and Spark are different things. Like Kafka is the message queue, right? Kafka is simply there to have a queue where you put stuff in here and it comes out of here, right? That's the only thing. Like a black box, put in stuff here, the other stuff, the other side, it comes out. And Spark can sit here on the other side and can then get the messages in its streaming, and it can then process these messages and transform the data, and also can take the other way around and put it back into a message queue or into a relational database storage or wherever, right? So those are the different things. Kafka is a message queue. It's there for yeah. Yeah, as a queue, and then Spark is for processing of data. Actually, maybe this makes it a bit more in my data engineering cookbook that I haven't updated it for a while, but here. So how you can see this when you look at the data platform, and this is still, I made this in, I don't know, 2019 or so. It's still the same. It works always the same way. You have a phase, you could call this connect, you could call this integrate, one where the data is coming in, right? You either host an API or you have an app there that actually then extracts data from an external source, like a warehouse, like a relational database, right? That's where the data is coming in. Then you can have 3 stages in the middle here: storage, a processing framework, and a buffer. And Kafka as the message queue, Kafka is here. Kafka is here. In the message queue is here the buffer. It's just for data is coming in, data is going out, and in a managed way. Where Spark is coming in, that's coming in as a processing framework, the actual way how you transform data. And you can have stream or batch processing here. Spark allows you to do both. So that's where you can see the difference, right? And then usually this flows from this flows upwards, right? Processing framework into storage, or buffer, processing framework, storage. And in the storages here, this is where you have your warehouse, your big data, your relational stuff. And on the right side, that's the other way. The right side, that's where the visualizations are. That's where your web UIs are. That's where your BI tools are. That's where your APIs for the mobile apps and so on, right? So the data flows from left to right here, but can take different paths. And that's the important part. So it could be that the data is coming in here. It's going to put here into, let's do this differently. Data is coming in here, and it's going to be stored in a data lake here. And then the batch processing is going to take the data from here, and it's going to write this into a warehouse there. And then your BI tool is actually querying the warehouse. One way of doing this. Or the other way around, for a streaming application, you have an API. The API is going to write data into your message queue here. Then Spark is going to actually take the data, do Spark streaming here, stores it somewhere in a data store, and on the right side here, there's your web UI that actually then visualizes the transaction that just happened. So data, it can flow here upwards, but generally from left to right. Right? I think that makes it a bit clear, the difference between these different tools. All right. Why choose EMR instead of Glue or Databricks? People are so I haven't used EMR, but people are telling me it's a nice way of actually hosting or running your Spark jobs in a, like, it's a I need to do this more, to look into it more. you can easily set up the infrastructure or on EMR to handle your jobs. I've only worked with Glue before for my courses, and I like how it works with Glue, but Glue may be a bit limited. Basically, EMR is just like a Spark cluster that you host, but you don't need to do the setup. It's very easy to host your Spark code there. With Glue, it's more for simpler tasks, made for simpler tasks. So I think that's the difference. Okay, where were we? Work scheduling. Absolutely Airflow here, right? Airflow is the main thing, but I've shown you up in the beginning cron jobs. Also good. So Airflow is still the main like the big dog in here. Monitoring of data pipelines. If you have Airflow, you can also monitor your data pipelines through Airflow. If you understand how you can use Elasticsearch and logging, then you can also visualize your logs through there and monitor your pipelines through there. So Prometheus is one of these tools. I think Prometheus makes sense. Students of mine have used Prometheus. I haven't used Prometheus before. Datadog, I don't know, Sentry. I'm just being ignorant of these, and I'm thinking if I don't know something, then it must not be very important. Here, Google Cloud, Google Composer. I don't know. Maybe Uzi. Forget about Uzi, Luigi. I would not focus on as somebody who's getting into this. I would also not focus on Prometheus in the beginning, but it could be a good addition. Networking. You should understand how IP networking is working. You should understand, I don't know, a firewall based on IP addresses. VPN makes sense that you know how a VPN works, but the other stuff you can learn on the fly. It's not a big deal. I would not make too much out of it. SSH you use very often for servers, to connect to servers, but yeah, it's something you can take a course on this. It's no big deal. Infrastructure as a code. The big thing here for me is Docker. That's the big thing. LXC, I don't know. Docker Swarm, forget about it. Mesos, forget about it. GKE? What's GKE? I don't know. Forget about it. I think that's something on Google. I'm guessing that's Google Kubernetes. The natural progression here is Google and then look into Kubernetes. Docker and then look into Kubernetes. The thing is, these platforms, like AWS or Google and so on, they have ways of hosting containers that are not Kubernetes, or you don't need to manage Kubernetes for container orchestration, like Fargate on AWS. So as a beginner, do not focus on that first. Okay. GCP Kubernetes. Okay. I was right. In relational data warehouse is already wrong. There is no relational data warehouse. There are relational databases and there are data warehouses, but the relational data warehouse is not the right thing. What are common data quality checks? Very difficult. I don't know what to answer to this now. Common data quality checks, mandatory to have. That always depends on your data, right? You want to have that the data is, that you don't have. So one of the big things is missing data. That's one of the big things. you most likely want to make sure. Everything else depends a lot on your data, and it's hard to generalize. What do we have here? CI/CD, then GitHub Actions makes sense. Jenkins, I wouldn't go for in the beginning. Active Directory, forget about these things for now. Identity and access management. It's like for a beginner, for somebody who's starting out, you are going to learn this once you need it, not before. Where we have legal compliance, encryption, key management, data governance, and integrity. Okay, let's move on. Visualize the data. Tableau, Looker, Grafana, Notebook, Jupyter Notebooks. So Jupyter Notebooks, these are the things. Very good. If you're working with Python, use these. And then I would go for Power BI. Forget and Grafana if you want to have a dashboard, a web user interface. Looker Studio was the old data studio on Google, yes. And Tableau, forget about Tableau. Power BI is for free. Use Power BI. If you understand Power BI, you understand the other ones. If you just want to visualize something quick, use a Jupyter Notebook. And if you want to build the dashboard, use Grafana. Great. Terminology for machine learning, forget about scikit-learn, TensorFlow, Keras, PyTorch. As an engineer, it's okay to know, but forget about that. Forget about that. You should understand the different supervised learning, unsupervised learning. Oh shit! You should understand that. You should. I mean, you should understand how machine learning works, and I put this here in the cookbook. Basically, that you understand what's a model, how does the model work, and how does the whole basically machine learning process work, right? You start with inputs, you do a training phase, and then the output of the training phase, once the output is good, you're going to put this into production. That means you're then going to use new data and show this model that comes out of the training phase. You're going to show this new data and going to generate predictions, generate outputs from this. And usually you monitor this, and once your algorithm is getting worse, you're going to re-trigger a training, and then you train you. So the live data is coming in production, and some older data you're going to train with is going to go into the training. I think that's the important part you need to understand. Everything else, once you work together with the data scientist, I think that's self-explanatory. TensorFlow extended, forget about TensorFlow, MLO, Kubeflow, Google AI platform, SageMaker. I would skip all of this. Forget about all of this. Would skip all of this. If I start out, focus first on the engineering part, and then later, if you're interested, get into these topics. Boom. That's already it. I hope you wrote down something. The recording, Peter. Are those live updated on YouTube, uploaded on YouTube, for example, in order to watch it from beginning? Absolutely. This thing is going to live on YouTube. I'm just going to change the number to 148. And then this is going to live there. So whenever you want to come back, go there. I'm going to add jump marks to the individual. I'm always saying I'm going to add jump marks. Most likely I don't have time for it, but you can scroll through it. Yeah, so much for this. Was there something that I missed that you think I should have added here. Otherwise, we're going to go into the next part. We're going to look at the Spotify data project that somebody did, and where I want to change a bit the architecture because I don't like the architecture. So let me know in the chat what you think about my analysis, my data engineering roadmap of 2023. If it's completely bullshit. If you want to learn this, basically almost everything that I added there, you can learn in my academy at learndataengineering.com. Check this out. Go there. Look at all the courses that are in there. Spark, DBT, Databricks, AWS, GCP comes next, a large GCP project, but we have something on GCP with BigQuery and cloud storage and Looker Studio. Like, there's more there than you ever need to become a data engineer or to understand data engineering. So, but I'm going to continue adding more stuff. Now, the next part. The next part was this message here. Where was that? That wasn't it. That wasn't it. This one here. So maybe we can save this image, save the downloads, and then just create a quick mirror board. To actually look at it a bit better and modify it. Come on. Okay. What do we have? The 230627. Okay, so and let's go through this together. Just need a quick sec to prepare it. Here's the image. Boom, boom. All right, and then I just want to, so this, I like this from Srikanta, and I'm going to read through this and show you the visualization for this, so you understand what is he talking about. Sometimes it's difficult on when I share LinkedIn with the with having text and image on together. So, what did he write here? He wrote here, this project aims to build a comprehensive data pipeline for extracting, transforming, and analyzing Spotify data using various AWS services. Right? So on the right side here, here's a Spotify API, a public API, and he's going to use that. The pipeline will integrate with the Spotify API to fetch relevant data and store it in an organized manner on AWS S3. So the goal is to at least then here put this into a cleaned data lake, or into a cleaned part of the data lake. So you could see this as the silver tables, the clean data tables of your warehouse, of your data lake. The extraction process will be automated by developing code on AWS Lambda, which will run at scheduled intervals or triggered events. So this here in the middle, this is, let me change this. I'm going to put this on the right here. So, one sec. I hope everything still works. Does everything still work? Because I muted here the browser. Yeah, it still works. So Lambda functions are here. The triggering is done by CloudWatch here, daily trigger with CloudWatch, and then the something works, right? It does the extraction with Lambda, and it does the transformation here with Lambda. So once the data is extracted, and a transformation function will be implemented to clean and format the data for further analysis. This function will be designed to handle various data processing tasks, such as data normalization, aggregation, or filtering based on specific requirements. Right? So it's the typical transformation part. Here comes the extraction part here with this. To ensure the pipeline's efficiency and reliability, an automated trigger will be built on top of the transformation function. This trigger will monitor for any changes or updates in the extracted data and execute the transformation function accordingly. So basically, I'm guessing this is the trigger here, the object trigger for S3. That means once something is coming into S3, a trigger will then start the Lambda function. Right? The transformed data will be stored back in S3, maintaining proper file organization and structure. This will allow easy access and retrieval of the processed data for further analysis. Furthermore, to enable seamless analytics, the project will involve creating analytics tables using Glue, here, the data catalog, and the crawler. The crawler will crawl the data lake, and then take the data, the information, and store it into Glue data catalog tables, and Athena for then querying the data from the bucket with SQL. That's the goal here with this. These services will assist defining the data schema and enable querying and analysis of the transformed data efficiently. By implementing this Spotify data pipeline, AWS project aims to provide scalable, reliable solution for automated extracting, transforming, blah, 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 blah. Okay, so could you build it this way? Yes, but I want to show you a few things that I don't like in this. So one thing people were asking here, from the architecture, it's appearing Python code is running in some other compute service and somehow it's triggering CloudWatch, but actually CloudWatch is starting the point of the pipeline. Which trigger first, Lambda, blah, 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 blah. So the Python logo here on the left, that is the question. And what he said here, as Jupyter is used to transform data prior to executing the Lambda process, the Python logo has been essentially added, right? So he is already doing some off the platform transformation, which I don't know why. I would not do this. That also makes, I'm not sure what then the extraction part here is, why he does the extraction. Usually what you want to do is you want to take this, I can't do it like this. Let me see, log. You want to take this here and you you go from here directly, you query the data directly from the API, right? That's one part. You want to have the transformation and the extraction in your Lambda function, not somewhere else. Don't use some kind of an external modifier to like, no, I would not do this. That's a bad choice. So the pipeline should look like this. There should be, whoops, the wrong thing. There should be CloudWatch. Or event. How's it called? I used this for one of the courses. Event. There's another service where you can schedule things on AWS. How's it called? Event bridge. Yes, yes, Mustafa, very good. Bridge, event bridge, exactly. So event bridge you could use, right? So I would go this on the left here. Here's the Spotify event bridge. This event bridge then triggers the Lambda function here. And the Lambda function then actually reads from here, right? Like this, boom, 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 here, trigger, read, or let's call this extract, right? Very straightforward. Lambda function extracts something and then writes it into S3. Let's call this here write as file. Okay? Pretty straightforward execution. Now, you could do this also differently. If you want to keep this first Python script here, you could still do this, but I would then do this differently. So what I would do, and I would always, when you have something external that writes into your data, into your storage, or into your platform, local Python script, right? What I would do in this case, I would go in there and I would remove this here, don't need this. But before that, I would sit here API gateway. And that is connected to the Lambda function. Never have a direct access into your platform. Always use a API in between. This way you can handle security for it. This way you have very well defined entrances to your system, very defined interfaces to your whole platform. Otherwise, this will be catastrophic. You're opening the doors for potential attackers. If you want to do this, you have an external piece of script, use an API in between. It's absolutely no problem, and it's very, very nice for streaming the data through, right? Data will come in, local Python script will process, will write the data into the API, and then the API will start the Lambda function automatically, and the Lambda function will process the data and will put it into S3. Pretty straightforward. But let's keep it here. So in this, now one thing was, I think the right side here, that's absolutely okay, except one thing. So let me put this here. Let's put this in the back. Let's remove this part here. Okay. Now, what he did here was he said, okay, once something goes into S3, it's going to set up and trigger, and then trigger the Lambda function. The Lambda function is then going to process the data and write it into S3. And from there, it's your standard data lake, your standard lakehouse thing that a lot of people use. Put the stuff into S3, into folders, define the data format in the folders, and then use some kind of query engine to query the data. Maybe partition the data in your S3 that you only are querying a small amount of data, or a reasonable small amount of data, and then it's absolutely no problem. The problem with this setup here, though, the big problem with this setup is, let's say this comes in here with S3. This triggers the Lambda function. The Lambda function starts, the Lambda function fails. You're screwed. You're absolutely screwed, because then you can't simply reprocess it, right? That's where queues are for. could say a message queue, but like something like Kinesis is overkill for this. What you can do is you can add here a queue like SQS simple queue service, and you write here into the simple queue service that basically the metadata for location, right? Let me make it like this, so it's a bit bigger and you can see it a bit better. Okay, right? So you have data is coming in, Lambda function extracts from Spotify, data is coming in, it's getting put into S3. S3, the metadata is going to be put into simple queue service, and simple queue service is going to start the Lambda function. Now the good thing, why would you do this? The good thing with this is that once the data is coming into SQS and it starts the Lambda function and the Lambda function is failing, it's automatically, the message basically is automatically going to reappear. So it's not going to be lost. It's going to be retried later again, right? And that's the big upside. So you would not, with these simple triggers, you would not use just the trigger. You would always want to do this with a message queue, and SQS is a message queue. This way you have the security of the event is happening, the event is going into a queue, and the event is going to be processed. And once the processing is finished in the Lambda function, it's going to tell this the queue, and the queue is going to remove that object. So the object or that message is not going to be processed again, and the file is not going to be processed again, right? So that's a big change in there. It's very minor change. The functionality is the same functionality, but the basically the overall functionality is an event is happening and the event is starting a Lambda function, but the middleman is different. We're using a queue, and that's why you would do it like this. That's why you would add a queue like SQS. I put on, did I put this on my Twitter again? Oh man, I'm bad at remembering. I think I put this on Twitter for you. There's actually a 5 reasons SQL Lambda triggers are a big deal. I put this here for you. So go to my Twitter, Andreas Kretz here, or at Andreas K. You are going to find me. I have a blue check mark because I gave Elon a few bucks. And here you have a resource that you can look through where, existing retry logic. Very important, super important. And also there are other things for practical use. Very helpful thing. Check this out. It's a good document. Slack is for monitoring and logging. What you could do is, okay, let's add this. What you could do is that, where's my Miro board? This was, here was it. You could say the Lambda function here, once the Lambda function is failing here, that you add here, that you put Slack in here. And that, I'm not sure if you can do this directly or if you would need a like simple notification service, SNS, but that basically then the Lambda function is telling a Slack channel, whoa, something failed here. Might be interesting, might be something you want to do, but Slack in this would be more for notification of people, what's happening, what's going on, right? So with this, otherwise this, let's remove the Slack part from here. So we'll go into SQS. SQS will start the Lambda function. The Lambda function is going to then process the data because it's going to access the data here. I think we need another here. We need another, I think I need to lock this again. How can I not make this snappy? I don't know how. So basically the Lambda function is then going to going to read a file here, read content, right? Because the SQS, the SQS part is only for the metadata. The metadata is flowing here and starting the Lambda function, telling the Lambda function what to process, but the actual Lambda function is going to read the content. It's annoying that I can't. Why can I just take this and drag this in here? Oh man. I think you get the point. You get the idea. And then it puts it into S3 as cleaned, as transformed data. And then you have your, also this is also wrong here. The crawler is, this also works differently. I'm sorry. I have to. This also works differently because your crawler here, let me see. We're going to do it like this. Your crawler is actually going this way. It's going to crawl the S3. It's going to figure out the tables or the structure of the data. It's going to write it into glue. Athena is going to use glue, so that arrow is also the wrong direction, right? And then what's going to happen is Athena is going to go here. Athena is going to access the data here in S3. There is no, it's not going to access the data in the data catalog. The data catalog is only there for you to show the structure, or that you understand that Athena understands the structure of the data in the folder here on S3, or in the bucket in S3. The connection here is going to be Athena is going to directly query the data from S3. So the arrows here are completely false. Yeah. But otherwise, I think otherwise it's a pretty straightforward project. I'm sorry, guys. Yeah. I actually only thought this needed to change, but as you can see, there's it. I hope you understand what I'm talking about, or why I'm saying this. So let's. It's absolutely not meant to trash the person who created this. It's just I want people to learn, and this is the way to learn, that somebody actually trashes your project. Lambda is great for processing stream data, but Glue is good for process batch data running then 15 minutes with Python. Yeah, absolutely. So the thing is, it's a good point. Good point, Mustafa. These Lambda functions are having a limit of 15 minutes per execution, right? So if they are going to time out after 50 minutes. If you write Lambda functions in this setup that we talked about, and these take longer than a minute, it's the wrong tool. The Lambda functions should be very, very quick. You're fucking up everything if this is taking very long time. You would not go in this and you would not set this event here to once a day. You set this to once a minute, once every 5 minutes. But you would not set this into that the data is coming in so big that these files are very big. No, don't do this. Make this small. This way you can also act on it, right? So if it starts in beginning or in minute 5, it starts to fail, this Lambda function, you can actually, you can act. If this starts to fail once a day, you already missed a whole day. So don't do this. Be small increments. It's always easier to work in small increments than with big data. Why am I saying this? Because you are going to drop your data here into S3. You are going to drop this into the buckets. And later, if you want to process data in large quantities, then later you're going to take the data that is in this bucket, right? You're going to take the data and you're going to then process everything together. there's absolutely no reason. The only reason for this, the only reason is if there are a lot of small files in here. Athena, for instance, hates small files. So what you would do is you would add another transformation step above here, and another S3, and basically you would say then you would you would consolidate the data. You would from, if you have 10,000 files in here, you would start this once a day. And let me see this. Can I make your lambda function? You would start this once a day and then write this as 1 or 2 files into there, or you do use glue here, right? So, okay. Mustafa, you can just write, I have a question. You don't need to shout here. It's possible to work with Scala function in Lambda and at the same time I develop Spark with Python in glue. I think you can create. Well, Scala is not necessarily Python, right? I think you can use Scala in Lambda function. Lambda expressions in Scala. Yeah. So that kind of stuff you can do. Spark with glue, yes, of course. Yeah. Okay, okie dokie. So I hope this helped. This is an interesting use case here. As you see, you can do a lot of stuff wrong just in a few minutes. But let me just copy this. Just want to take everything here. This is locked, that's why I can't use it. And then I want to later post this, but without the 10K and the other arrows. This I want quickly. Oh man, I want to quickly delete these. Because I want to also tell this to the one who created this, so that he knows what he can do. Can we do all this with Docker? You could, yeah. Well, what you can do is you can use Docker in this, that you write a Lambda function that is based on a Docker image. That's absolutely possible, and then you don't even need to host it. Yeah, because all the dev people like dev local, then use console. What? I'm not 100% sure, but you could build all this. You could build all this in as containerized applications, right? These are just Lambda functions here, Lambda here, super easy to do. This again, I would schedule with the cron job, very simple. Okay, SQS you can't do the right part here. You can't have on local, but the simple processing, yeah, you could develop this as Docker containers and then use these Docker containers for the Lambda function. Possible. Absolutely possible. Okay. That's enough for me. We're in 1 hour 14 minutes and live stream number 148. So I hope you had fun. I hope this helped you a bit on your journey, on your data engineering journey. For me, these things are always fun. I'm going to do this more often. I'm not sure about tomorrow, because tomorrow I'm on I'm on a birthday party. Maybe tomorrow if we start earlier. If we start my 3, that would be 9 a.m. in New York and 6 a.m. in Los Angeles. It doesn't matter though. You can always watch the recording on YouTube. By the way, if you're on YouTube, hit the like button on this and do me a favor. Maybe write a comment afterwards. Yeah, and then we see each other next time. If you want to, also, don't forget, if you want to learn data engineering, learndataengineering.com. Right. Quick plug at the end. See you tomorrow. I'm going to let's see tomorrow. I'm going to plan it in for tomorrow, and then we're going to start earlier. If you have something interesting you want me to see, by the way, use Twitter. Add me on Twitter. Post the document. Add me on Twitter, and then I'm going to check it out, and we're going to look at it tomorrow. Right? So, bye. Have a good one. Quick drink at the end.